Dear students, in this video I will be talking about orthographic views. The main objective of this video is to draw the orthographic views from the pictorial view and to get the initial settings, to do the initial setting to draw the orthographic views, to get the analytical skills to draw the orthographic views. Here you need to first understand about a pictorial view or single view. If you take elephant as an example, and if you see the elephant in one view, it will appear in this manner. And from the front, if you see the elephant will be appearing in the another manner. And the same elephant, if you see from the top, it will appear like this. By seeing any one of this view, we can't able to get the full details about the elephant. So we need some other view from where we can able to get the full details. Now if you take the photo of this elephant with some angle, not from the side or front or from the top, from some side with 45 degrees angle from the elephant, and then some height also from the elephant, so the elephant photo will be appearing like this. So this is called as a pictorial view or a single view, which give the maximum details in one single view. It will give maximum details possible. That is called as a pictorial view or a single view or three-dimensional view of this object. And if you take another example, now let us say a house. If you see the house in this manner, you can able to get the maximum details about this house. By seeing this pictorial view, we can able to assess the front view, side view, top view, etc. So this is called as a pictorial view, a single view which gives maximum details about the object. And these pictorial views are three different types. Those are perspective view, oblique view and isometric view. And the perspective view is nothing but when you see an object with our naked eyes, how it appears. In the same manner, if you draw the diagram, that is called as perspective view. And here this is very realistic in nature, but it is very difficult to understand because this edge of this object is very near to you, so it appears with the longer dimensions, and this edge is away from your eyes, so it is appearing like a shorter dimension. So in this perspective view, the dimensions will change along with the distance from the observer. So that is why it is very difficult to draw, and that is why they implemented oblique view. In the oblique view, we will be assuming that any one plane is perpendicular to the view direction, and other two we will be deforming, and then we will be drawing the projections. So this is also, it is easy to draw, but it is not realistic, and that is why this is not in use. Next one is isometric view. In this isometric view, object will be rotated in such a way that all these three views, all these three planes will be appearing with the same angle. Now if you observe the angle between these three lines in a perspective drawing, and these three are not at all equal. But in oblique projection or oblique view, if you see, this is 90 degrees and these two angles are equal. This is 133, 135, 135. So these two angles are equal and this is 90 degrees. So this is oblique view, but this is not a realistic object. And if you see the isometric view, in the isometric view, this angle is 120 and this is also 120 and this is also 120, so total 360. So this the drawing is drawn by making all the planes with this equal angle. So this is called as isometric view. So in our orthographic views, we are going to convert this isometric drawing into orthographic views. That is only our main objective. And if you take this as an example, this is a pictorial view or three-dimensional drawing, and this we need to draw the front view, top view, side view of this diagram. That is only orthographic views. So in projections of solids, we used to imagine the solid between the planes of projection, and then we will be drawing the front view, top view of that object. But here they will be giving a three-dimensional drawing, and this three-dimensional drawing we need to understand, and we need to assess how the front view, top view, side view of the diagram look like. And wherever they give the arrow mark, that is called as the front view. That is the front view. We are assuming that as a front view. And now if you assume this is as a front view, and front view will be looking like this, and if you assume this is as a side view, so because it is a this is the top view, so top view will be drawn below the front view, and the side view, this is the side view will be drawn on the left side. This is the left side view. The left side view will be drawn on right side, and right side view will be drawn on left side. So here simply we need to remember that they given the left side of the drawing, so that will be drawn on right side. The top view is drawn on below front view, and front view will be drawn first. So usually front view will be drawn first, then we will go to top view, and then we will go to the side view. That sequence will be more easy to complete the drawing. Let us take one more example. Let us assume that this is a pictorial view or a single view, and we will be assuming that these are the planes of projections. So if you view this from this side, and it will be appearing like this, these three planes will be appearing, these three planes is drawn on this profile plane. And if you feel this is the front view, and if you see the object from this side, that the plane surfaces will be drawn on this profile plane, and the top view will be drawn on this horizontal plane. So here also it is little different from projections of solids. In the projections of solids, regular solids will be given and we need to imagine, but here the object will be given, that we need to try to understand as a one three-dimensional object, and then we need to draw the front view, top view, side view of the diagram. And if you want to solve this orthographic projection or the orthographic views, so you need to know about the types of surfaces. Types of surfaces. There are four types of surfaces. If you know about this, orthographic projections will be easy. The first one is principal surface. The principal surface is nothing but if the surface is parallel to any one of the principal plane, that is called as the principal surface. Now if you observe this object, this blue color surface is parallel to vertical plane, so this is the principal surface. And this yellow color surface is parallel to profile plane, so this is called as the principal surface. And green color surface is parallel to horizontal plane, so it is a principal surface. Any surface which is parallel to any one of the principal plane is called as the principal surface. And these principal surfaces will be visible with the true dimensions in any one of the view. Because this is the principal surface, it is appearing with the true dimensions in the front view. So that will be drawn on vertical plane. And this is the principal surface which is appearing with the true dimensions in the top view. So that surface will be drawn with the true dimensions on the top view. And the side view, this yellow color surface is the principal surface. It will be drawn with the true dimensions on the profile plane. So likewise, we will be drawing the principal surfaces first. That is, and then we will go to the inclined surface, smooth surface, and then curved surface. What is meant by inclined surface? If the surface is inclined to any one of the principal plane, that is called as the inclined surface. Now this is making some angle with the horizontal plane. So in that case, this surface true dimensions cannot be seen in the front view or in the top view, but we can able to draw in the two views. So because it is inclined, true dimensions cannot be taken. So we need to identify the corner points in the views, and then we will be connecting all these corner points in the remaining two views. And if suppose if you draw the front view, so this corner point is locating here, this corner point is locating here, this corner point is projecting here, this corner point is projecting here. So we will be drawing or connecting all these three. And this is not the true shape of this size of this plane surface. But the inclined surface, because it is inclined to one plane and automatically it will be inclined to other plane, so the surface will be visible in two views. So here the surface will be visible in this front view, so the front view is drawn, and again in the top view also surface will be visible. but that will be drawn on horizontal plane. And these two surfaces, one surface only will be visible in two views, but both the views dimensions are not the true dimensions of this surface. So that is the inclined surface. That is why first we draw the principal surface and then we go to the inclined surface. Then we go to the skew surface. Skew surface is nothing but if the surface is making angle with all three principal planes, it is called as a skew surface. So here this skew surface is making angle with the horizontal plane, vertical plane and profile plane, and this surface will be visible in all three views: front view, top view and side view. So we will be identifying these corner points onto the planes of projections. Then we will be connecting all these corner points to get the projections of this plane surface in all three views. Next one is a curved surface. The curved surface boundaries we will be deciding, and then we will be drawing the projections of this curved surface. So likewise we need to identify the principal surface, then we need to draw the principal surface first, and then we need to go to the curved surface and hidden lines. Now if you see the procedure to draw the projections of solids, so identify the principal surfaces and draw them in the corresponding view. Locate the corner points of or corners of the non-principal surfaces. Non-principal surfaces are nothing but inclined surfaces and curved surfaces, skew surfaces. And these surfaces boundary points are the corner points we will identify, and then we will connect the points, and we will complete the view. And then satisfy all visible surfaces in all three views. If it is not visible, then we will be indicating that as a hidden line which is not visible. So then we will be completing. Let us see some examples. Let us consider this diagram, first diagram, and arrow mark is given here. The first you need to identify where the arrow mark is given, and whichever the direction arrow mark is given, that indicates that is the front view. And if you see the front view of this object, so this object we need to imagine between the planes of projection. As the arrow mark is given here, the principal plane, vertical plane, is parallel to this yellow color. So when you draw the view this object from this side, so you can able to see this surface which is yellow color, and this yellow color is principal surface. So directly we can take the true dimensions of this surface, and then we draw the vertical plane. So vertical plane I am assuming here. So these dimensions are 45 and 15, 15 and again 15, 15, 15, 15, 15. So this inverted T shape I can draw in the front view, and that is on vertical plane. So I will be drawing 45, 15, 15, 15, and then I will complete this front view. So then above this view I will also write here that the front view, and I need to give the dimensions. When you draw the projections, make the thickness of the diagram with up to 1 mm, and these other lines are the projection lines that can be 0.09 mm or 0.05 mm. So very thin lines. Now once after you draw the front view, you need to draw the top view. So if you see the object from the top side, this blue color, the surfaces will be visible, because these blue color surfaces are principal surfaces which are parallel to horizontal plane. When you are seeing exactly from the top, you can able to see these three surfaces one after the other. So, and this red color surface will not be visible in the top view, because this is perpendicular to the ground. So when it is perpendicular to the ground, and when you are seeing the principal planes, so this plane will not be visible and it will be appearing like a line. So this red color surface in the top view will be appearing like this. It will not appear actually, it will appear like a line, and this red color surface appears like a line in the top view. So I will be drawing first this the principal surface, that is 15 by 30. So I can make some gap between the front view to top view. So I will make like 15 mm, and the same distance I will be maintaining from the distance from front view to side view also. So that will be the good way of practice. So here I will be taking some convenient distance, that is 15 mm, and then I draw this surface first here. Next to this another surface also there, and this third surface is, it is appearing like a triangle, but it is actually a rectangle which is behind this the projection. So we only a few, little surface of this surface is visible, but it is also same like this. It is also same like another the plane like this. So I will be drawing the other plane this way. So like that, these three surfaces are one after the other in the top view. Then if you go to the side view, these red color surfaces are visible, and these green color surfaces will not be visible when you are seeing perpendicular to this the principal surface. So these two I will be, because it is appearing on the right side of the object, so I can get this on the right side view, but right side view will be drawn on left side. So take this dimension 30 by 15, and you will draw these two surfaces. So this is how you will be completing the projections, orthographic views for this diagram. For example, if the same diagram, if they give the arrow mark here, how the views will change? So if suppose if you follow the arrow mark here and draw, when they give the arrow mark here, then you will get 0 marks. So better we need to see where the arrow mark is given, and you need to start the project views from that point. So now they given the arrow mark here, so this becomes the front view, red color surfaces, that becomes the front view. So if you draw the front view of this red color, so the front view will be looking like this. So 30 by 30, and between these two surfaces are separated, and these two are separated, so that will be separated by this line. Then we need to draw the top view. If you see the top view, same the principal surfaces will be visible in the top view also, but now these two will appear one after the other horizontally. So because the arrow mark is given here, this becomes the front view and this becomes the top view. So that means when you draw the front view like this, so xy axis or xy reference line is here. So when you draw the top view, also the xy reference line will be here. So that means these two will be coming below the xy reference line. So this surface, these three surfaces will be drawn below xy, and this is drawn the front view, and this is the top view, and then side view. This becomes the side view, yellow color one, and the yellow color the surface will be drawn here, and this is the side view. So the front view, top view, and side view are drawn here, and this is the pictorial. So that means based on the arrow mark, the views will change. Views are same, but the orientation of the views, the position of the views will be changing. So we need to carefully see, and then we draw. Another example, if you consider, this is another example, and arrow mark is given here. So first you need to identify the principal surfaces. This is the principal surface, this is also principal surface. These two principal surfaces are parallel to vertical plane, so we will be drawing these two principal surfaces in the front view. So with the true dimensions, so we know the dimensions. This is the 85 by 45, so draw 85 by 45 on the drawing, one view, and then we need to draw another principal surface which is behind this, but this principal surface will not be visible in this direction, because when you try to see that, this surface is hiding this surface, so this becomes the hidden surface. So the hidden line, this line will not be visible in the front view. This line is not visible, but it is hid by this, but this line also will not be visible because it is hid by this, but these two edges will not be visible, but there is nothing to hide here. So that is why we will be indicating this with the dotted line. Then we will go to the top view. If you see the top view, and we will get this C shape, and then this another two the shape. So these two are principal surfaces. We will be drawing these principal surfaces with the true dimensions, and then we go to the side view, and this they given the left side view, so that will be drawn on right side. So then yellow color, four surfaces one after the other will be visible. So that is how we will be drawing the projections. Now these are only a simple examples. When we solve the problems simple to complex, then you will able to solve easily. So now for solving the orthographic projections or the views, I will be using these diagrams, and these diagrams are given in the mesh or in the dots. So here if you take any one, here the difference is the gap between the two mesh or the dots are 10 mm. 10 mm. So likewise all these drawings we can able to draw, because I need not to give the dimensions every time. So that is why I have taken this diagram as example, and this is the arrow mark. This all arrow mark indicates that is the front view. So we will be considering these all diagrams and then we will be drawing. Then we need to do some initial settings also to draw the orthographic views. The first one is grid style. In order to make the dots in the AutoCAD screen, we will change the grid style to 1. And grid display, specify the grid spacing. Grid spacing we make 10 mm. And snap, in the snap spacing also we make 10 mm. And then we can able to easily draw these orthographic views. Now we draw orthographic views in AutoCAD. Initially you will open AutoCAD, then you will go to open the template, and in this template previous drawings you will delete, and the remaining layout you can keep as it is, and the title you can change it as Orthographic Projections. And the remaining things you can change the date, etc. Now you need to do some initial settings. Now the grid is off here. You can on grid here in the status line. You can just on the grid. You can able to see the grids here. Then you go to grid style. Change the grid style to 1. Now you can able to see the dots here. Then you also change the grid spacing. For that you type grid and enter. It will ask grid spacing, you make 10 mm, because the line to line 10 mm you are seeing. So now this grids we will be using for drafting purpose. Then now the cursor, if you take a line or something, the cursor is moving freely. So I wanted to restrict the movement of the cursor also from point to point, so that I can directly select one point to another point. So for that I will type the snap and then enter. Snap spacing I will on 10. Now if you take a line, now the cursor will be moving from one point to another point only, so that I can directly draw the projections or the views very easily. So this is how you will be doing the initial settings, and you will prepare the screen suitable for the orthographic views. So now we will try to draw the first diagram. So I strongly suggest that this the worksheet you can take a printout, and then by seeing the diagrams you can draw the projections. Now if you go through the first diagram, this is the first one, and this you will try to draw here. So now initially where to start, we need to first see the arrow mark. So here the arrow mark, here it is indicating the first front view. So we will be drawing the front view. So take a line command, and the line command we will be starting from here. So this here, the space between the two dots, is 10 mm, and here the space between these two dots also 10 mm, and space between these two also 10 mm. So we will try to understand the dimensions of this diagram from the dots. So there are 1, 2, 3, 4 dots are there. So the width or the length of this line is 40 mm. Height of this line is 20 mm. So this is the first principal plane which is parallel to vertical plane. So we draw this surface in the front view, on the vertical plane. So now first we will be drawing this line. So take a line command. So line command, so 40 mm, so 1 2 3 4, so 40 mm, 20 mm, 20 mm, 40 mm, 20 mm. So we completed the first this space. After you complete this surface, you can also notice that there are 3 dots here, and at the center there are 3 dots again. So in the similar manner, that is why if you proceed with these dots, you can able to understand how these surfaces are looking like along with the dots. So if you complete this worksheet in this manner, so you will get some imagination skills. Then we can go to the next worksheet, which is actually without dots. So now in the front view, this is the one principal plane and this is another principal plane. We can see this also we will draw with the true dimensions. So this is another principal plane, but this is parallel to the ground, so this will not be visible in the front view. So this is another principal plane we will be drawing. So take line command, so complete the plane also. So this becomes a front view. Then you need to draw the top view, the below this front view. So if you draw the top view, this is the top view which you can draw, and if you see the top view, this is the first surface which will be appearing, and below that you will be seeing this surface. So you take a some 10 mm gap between the front view and the top view. So then you will be drawing the front view, the top view here. So now you take line command again, so draw the surface. This is the 40 by 20. So this surface I completed, that is here, and again in the top view this is another surface that you will be drawing below. So again you complete this surface also by joining these dots. So after joining, these 3 dots are here, these 3 dots are here. So this is the top view. Now you will be drawing the side view, and in the diagram, 3D diagram, the left side you can able to see, so this is the left side view. The left side view will be drawn on right side. So this is the front view. The next to the front view you can able to draw the side view. So now you take a line command, so draw L shape by connecting the dots, and the 20 by 20, the similar to this. So because this line is starting from here to here, so I draw one line here, then from here to here I draw another line. Again the line is going like L shape. The L shape I completed here. So you can also cross check the dots. So there are 5 dots which are in L shape. So this becomes the side view. Now you can type here the front view, side view and top view. So take it the text command, or otherwise you can is the earlier one, so you can take this projections, and here this is like so now the snap, it will be moving from one grid to another grid only. So you can paste here. This you can type as front view, FV, and then you can move this. Is the front view. So you want to move again exactly here. So snap you should off. So if you want to off the snap, you can go here, or otherwise simply you can press F9. If you press F9, snap will be off. So now you move freely where you want to move, and again you wanted to make the side view here, you can keep side view, and the top view over here, so you can keep the top view here. So this is the top view, so you write TV, and this is the side view, you can write SV, and you also need to give the dimension, because actually grid is there, so you need not to give the dimensions, but better we will be practicing giving the dimensions. So we will take the linear dimensions, and this is 40 mm, so you can give 40 mm dimensions here, and this is also 40 mm, so this is the 40 mm, so we can give dimensions here, and this dimensions nowhere is given, so you will take this dimension here, and this height also you can give dimensions here. So with this the first diagram is over. So you try to, this is the first diagram and its answer, so we will also keep this the question number at this place. So this is the answer for the first diagram, and that is at this place. So we can also move this at one side. So in one layout we can hardly draw only 2 diagrams. So this first diagram is over. Now for drawing the second diagram, we will again go to the second the diagram here. So you can just move the diagram here. So this is the second diagram. So now we will try to draw the second diagram answer here. So now again, now you see the arrow mark is continuously given here. So this arrow mark indicates this is the front view. So take the line command, and then this is the left side view is given, so that will be coming on right side. I need to draw the front view here. So now again, now the snap I need to on. So press F9. So if I press F9, it will be moving one grid to another grid. So now I will complete the front view first. So 40 by 20. I will complete the front view. Now here if you see, this is like a triangle appearing. This is also principal surface that you can able to see in the front view. So draw this triangle. This is the front view, and top view if you see, this is the inclined surface, and this is the top view. This is the principal surface. So first whenever you wanted to draw, you need to first draw the principal surfaces, then you will be drawing the inclined surfaces. So if you draw the principal surface, this is the principal surface, this is the inclined surface, 20 mm is that below 20 mm, you need to draw this principal surface. So here you will get the inclined surface, then the below that you will get the principal surface. So you complete this principal surface, which is 40 by 20. Then if you want to draw this inclined surface in the top view, first identify these corner points. Identify this corner point. This is the one corner point. That corner point is here. So you need to, this corner point is here, another corner point is here, that is here, and these two corner points are here and here. So now you can easily draw the inclined surface by connecting these 4 points. So in the top view exactly it will also look like a rectangle only, because it is the inclined surface. It will, in the top view it will appear like a rectangle. Now you go to the side view. In the side view if you see, this is the principal surface. You draw the principal surface first, that is 40 by 20, and then inclined, this is the inclined surface. So this point you need to, these are the 4 corner points you need to identify. This corner point is here in the side view. So this is the first corner point, this is the second corner point, third corner point, fourth corner points. 1 2 3 4 corner points are 1 2 3 4. So you already got the corner points here in the grid place. So you can connect 1 to 2 and 2 to 3, 3 to 4 and 4 to 1. So this is the inclined surface, but it is appearing in the side view like this. So again you can also give the dimensions and write front view, top view, side view according to here, and the question number also. Now you can go to you need not to write again the same thing, front view, top view, side view. You copy this and this question number also, and copy, and then take the copy and paste here. So this is the question number 2. You can just edit the question number, and dimensions you can give. So this how we can complete the 2 diagrams. Then now because in orthographic views, front view, top view, side view, we will not change the colors. So now we will go to the other place. So this is the sorry, now I will take copy these diagrams and I will paste here. Okay, so this is the first diagram, and now I will delete this here only, because I kept the grids here. So I will delete this. So this, now I will draw second and third problems. So if you see other problems, so similar way you can able to draw all the diagrams. So this is also all similar diagrams. So let me explain this third question, because here is the skew surface. So now let us go to this skew surface. So this diagram, fourth one. So how to draw this fourth diagram? So here, to draw this again, what you do, you go there and take a line command. Now this arrow mark indicates that this is the front view. So now this is the side view. Side view is the right side view, that should be right drawn on left side. So you leave some space here, and then you draw the front view here. So now to draw this front view, this is the principal surface and this is the skew surface. Skew surface we can't draw first. So first you draw the principal surface. So principal surface, this is the 50 mm. So draw 50 mm here, starting from 1, 2, 3, 4, 5. And then the height of the height here you see is 10 mm. 10 mm you draw, and again you start from this side. So this is the 40 mm height. So take 40 mm here, and again 20 mm this side, and then it is coming and joining to this initial point. So initial point. So now this is the front view principal surface. Then I will be drawing the top view. The top view I will draw with some gap, the 10 mm. So I will take a line command. So I will draw starting from this point, or otherwise from this point I will draw, or because this is the arrow mark, this is indicates the front view, and if you see the top view, and this line will be nearer to this front view. So this line I will first draw. This is the first to draw. I will draw this line, and 10 mm I will draw this side. Again 40 mm down. So 40 mm down I will draw, and again 20 mm this side. So this line is joining from this corner point to this point. So again you will be joining these two lines. So this becomes the top view of this diagram. So now I will draw the side view. This is the left side view. Right side is there mentioned, but that will be drawn on left side. So I will draw the left side. So now I will draw this principal surface, and this line will be nearer to the front view, because when you draw the side view, and this line will be nearer to the front view. So you will take a line, and this line you will draw this line, and again 40 mm and 10 mm up, and here also 10 mm. So this I completed this surface, and these 2 points I will join along with this, and this is 40 mm, and this is also 40 mm and 40 by 40, and then I will be joining these two, so in the side view. But how 1, 2, 3? So this is a 1, 2, 3, 1, 2, 3. So I need to draw one more. This is only 30 mm I have drawn. 1, 2, 3, 30 mm. 30 mm only I drawn here, sorry. So I need to change this actually. This height is 40 mm. The height is 40 mm, but I have taken only 30 mm. So I will draw one more grid. Then if I draw the 20 mm here, this becomes the front view, and in the top view also this is 40 mm. So I have taken only 30 mm by mistake. So I will be taking one more grid, and then the 20 mm, and I will complete. So after that is why when you after completing, you also cross check with the grids. These grids will appear same like how it appears in the top view, and these grids also appear same like in the front view, and side view also these grids will appear same like that. So now this is now I will complete this. So this is the 40 by 40 and 10 mm up, and again I will be drawing one more line here, and I will join these two lines, so that see here the grids, it will appear same like this. So that is how you can able to cross check if you use the grids. So that is why I told you first we will complete with the grid, the 3D, and then we will go to without grid. So now this is the question number the 3. So you can copy question number, and you can give the dimensions, and you can also copy the question number from here, and I will keep the question number over here, and this is the question number 4. Question number 4. Then we can even move, this is one side, so I can move this. So now this is actually not completed, and there is one more skew surface is here, and this skew surface you need to complete. This is skew surface, how to draw. So take a line command. It is starting from this corner point in the front view. This corner point, these are the 3 corner points of the skew surface. So in the front view, this is the first corner point, that is here. Second corner point is this, and third corner point of this skew surface is this, and this is exactly at in the rectangle. If you consider the rectangle at the top most left corner, right corner, so this is the third point. So you join these 3 points to complete the skew surface. So starting from this to this, and I will be joining. So this is a skew surface in the front view. And in the same manner, this skew surface will appear in the top view. This is the first corner point, second corner point, and third corner point is the in the rectangle, the bottommost right corner. So this is the first point, second point, and bottommost the right corner. This, so you can draw complete the skew surface here. The same manner, the side view also. This is the first point, that is this, and second point is this. Already it is joined, and the third point is here. So you can join this third point with this. So these are the three skew surface, and with this it is completed. Now if you go to the next problem, so this problem you can also complete, and these all problems are easy. So let me complete this problem. So this problem, it is like a curved surface, is there, curved surface. So now this indicates the front view. So front view, it is like a square box. On the square box there is one cylinder is resting. So first I will be drawing the principal surfaces. So this is the principal surface, so which is the drawn, and the outermost corners are a square. So I need to draw this. Other full square is not visible, but because this projection is hiding the other edge. So first we need to start from the front view. So the front view, it is starting from 40 by 40 and one square. So this is like a the side view, front view, and the side view is, whenever you start with the front view, you first check which side view is coming, whether it is the left side view or right side view. This is the front view, so this is the side view. Side view is given at the left side, so it will be drawn on right side. So now if you go there, so if you see this diagram, yes, so this one, so I will draw this solution over here. I will draw. So now I will first draw the front view. Front view will be drawn this side, and side view will be that side. So first I will take a line command, or otherwise directly I can take a rectangle, but for you to understand easily, I am taking the line command. So line command 40 by 40 and 40. So this is the square, one square, and that is the drawn. And here this is the another principal surface that is inside this square. So now you can take the circle and radius, and this is the center point of the circle, and this is how the principal surface is appearing in the front view. So with this the front view is over. Now you go to the top view, and if you go to the top view, and this is the line which is near to the front view, so I will be drawing the front view, this surface, principal surface. So take line command, and then I will draw that principal surface. Then I need to draw this curved surface, but this curved surface I will draw later. But first I will complete this principal surface in the side view. So this principal surface, if I draw, this is the edge which will be near to the front view. I will just draw that edge 40 by 20 rectangle. So this rectangle is coming here in the side view. Now this curved surface will appear in the top view, and this is curved surface boundaries are this. These are the boundaries, and this is the another boundary, that is nothing but a curved line, and this line I can see in the top view like a line, and this is the another curved surface line, and that will be coinciding with this line, and this boundary is this, another boundary will be that side. So that means it will also appear like a rectangle only in the top view. So this boundary line I will draw here, the 20 mm, and another, this arc will appear like a straight line in the top view. So that will be this, and again I need to close this. So here if you see these two, this is the rectangle surface, and this is the curved surface. These two will appear same manner in the top view. Now if I see the side view, this is the rectangle which I can see here, and in the side view also this curved surface will appear, and this is the boundary. This is the one boundary, and this curved line will appear like a straight line in the side view, and again another boundary. So take a line command, and complete this line command like this. So with this this is the front view, top view, and side view. So this is the question number the 5 something you can draw right here. So I will take the question number also here. So question number I will copy and I will keep here. So this is the question number let us say 7. So with this some diagrams over. Now let me make this diagram. So this is also similar to that, but it is little we need to see the hidden line also. So now before that I will copy this. So again I will copy I will copy this diagram. So I will keep here. This I will delete. So let me draw again here in this place. So now I will try to draw this diagram. I will try to draw this diagram. So this diagram so this diagram front view is given here. So this is only one principal plane is given. It is this plane. So I will draw the front view, and this is the right side view, and that will be drawn on left side. So I will be drawing the front view this side, so that this side view will come. So now first there is a deformation here actually, otherwise this grid is actually coinciding here. Okay, so there is a little deformation or maybe shift happen. So now this is 40 mm. So if you take a line command, so 40 mm I will draw here, 40 mm, 1 2 3 4, 40 mm, and again 20 mm up it is going. Then again this is 40 mm up, 40 mm up to here 40 mm. Then there is one more line, it is 20 mm, that is here actually. Now if you see, there is arc, this is the starting point, this is the ending point, this is the starting point, ending point. You can take the arc, start, center and end, start, center and end. This is the starting point, this is the center point, and this is the ending point. So it is coming in the reverse direction. So you take, this is starting point, this center point, and this is the ending point. Sorry, arc, start, center, end, start, center, end. So this is the starting point, this is the center point, and this is the ending point. Again take arc, this is the starting point, this is center point, and this is the end point. So that is how I draw this principal surface. This is the front view. Now I will go to the top view. If I go to the top view, this is the curved surface, but this curved surface boundaries I will identify. This is the one boundary. So I will draw the curved surface here. So I will be drawing exactly below. So take a line command. So this is the first line, boundary, curved surface boundary. So I will draw this line 40 mm, and another boundary is this, and this is making 20 mm distance. So I will draw line here, and there is one more boundary, and this is the another another line which is actually coinciding with the below line. So this is the another boundary of the curved surface, and this is another boundary of the curved surface. So this is how I complete the, and this also a curved surface, and this a principal surface till here, and then this is a curved surface, this becomes another boundary. So I will draw and complete this, the curved surface in the top view. So this is how the top view will appear. So this curved surface will appear like this, and this curved surface will appear like this. And now I need to draw the side view. That is the right side view should be drawn on left side. So I will take 10 mm gap here, 10 mm gap, and then I will draw the side view. So I will be drawing this side view from here to here, and this line is nothing but, so this here if you see the side view, this curved surface will appear like a plane surface, and this is appearing like a line. So that is another, the horizontal line, and this also will appear like a vertical line, and again this curved surface line is appearing like this. But here this till here the curved surface, and it is continued by the principal the surface. When these two are coincide, we will be not showing any line between, so it will be a plane surface. But here there is one more thing, and here also there is a curved surface, but in the side view this curved surface will not be visible, so it becomes a hidden line. So this is the hidden line. So this is the hidden surface. So that hidden surface boundaries are this is the line, but that line is coinciding with this, and this is another hidden line boundary line of the hidden line surface, and that is coinciding with this. Another boundary line of the hidden surface is here, but that is not coinciding with anyone, but that we need to indicate here. So the hidden line we need to show from here to here. So this becomes the hidden line, and that is actually the line between these two, the curved surface. So this is the hidden line, so we need to change the properties. So match properties, this is the hidden line, so snap I need to off. So F9, you press F9, so change the properties to this, so because this is the hidden line. So this is how you can able to draw the another diagram. So this is the question number 8, so I will keep the question number here. Then next we will go to another diagram. So now let me let me move this, sorry. Now let me go to another diagram. So one or two diagrams I will explain. So likewise we can complete this all diagrams, very simple, and I will try to explain two more diagrams. So let me explain this diagram. So this is one complex diagram, and maybe one more diagram, maybe I can explain this diagram. So these two diagrams I will explain. So let me explain this diagram first. So if you see this diagram, so try to understand how it is looking like. So that I will draw here. So let me complete this diagram here. So question number, you can see where it is coming exactly, sorry. So both I am using parallelly. So now I will start this diagram here. So now first I need to start with the front view. So the front view I need to start. So where is the arrow mark, that I need to see where the arrow mark is. So arrow mark is here. So I will be drawing the front view. So this is the first principal plane, principal surface on the front view. So I will draw the front view here. So I will take a line command. So now I will draw the front view here. Now I will on snap F9, so that I can move point to point. So this is 20 by 1, 2, 3, 4, 5, 50 mm. So 20 by 50 mm. So I will draw the front view with 20 by 50 mm, 20 by 50 mm. So here up to 50 mm we have drawn 1, 2, 3, 4, 5, and again 20 by 50 mm. So this is the first principal surface which I have drawn here. So that is why we need to first start with the principal surfaces. So now I will draw the top view. If I go to the top view, this is the first principal surface on the top view and the second principal surface on the top view. So first I will draw this. This is again 20 mm. So this is the line which is very near to the front view. So I will be just drawing that line. So this line I will draw. So that is this line. Now this is the 20 mm. So 20 mm I will draw here, and I will complete the triangle. So this triangle principal surface is here. Now this is another principal surface I will be drawing here, and you need to first identify this corner point. This corner point is from here to here 40 mm is 40 mm. So that means here to here the 40 mm, this is the corner point, and I need to take 20 mm here. So take line command from here to here 20 mm, and this is 50 mm length to draw the triangle. Again I need to join this. So this is the principal surface which is drawn here, and this is the top view. So then now I will go to the side view. Side view is drawn on the left side, because this is the left side is given. The left side view will be drawn on right side. So L shape I need to complete in the side view. So this is how much height? 1, 2, 3, 4, 5, 6, 60 mm. To take line command, and this corner point will be starting here. This corner point will be starting here, and now 1, 2, 3, 4, 5, 6 mm or 60 mm. Now width is 1 to 40 mm, so 40 mm line I will draw here, and then the height is given 20 mm, again 20 mm down, and L shape I will complete, L shape. So this is the L shape, I got it, and if I check the grids also properly placed here. Then this is the one principal surface which is in the side view. So now I completed all the principal surfaces which is appearing in the front view, top view, side view. Now I will go to the inclined surface. So if I go to the inclined surface, starting from the front view, front view there is no inclined surface. In the top view we can see one inclined surface. This is the inclined surface. So now you identify this corner point. Where is this corner point? In the top view. In the top view, this corner point is here, and that is over here. This is the first corner point, and this is the second corner point of this inclined surface. This inclined surface other corner point is here, and this is the third corner point. This third corner point is here. Fourth corner point is here. So all these four corner points are known. So take line command. So join this all. So here and then here to here. So this is the inclined surface which is here. So in the top view we can able to see this inclined surface. So these three surfaces are visible in the top view. So we have drawn, and then we will go to the front view. In the front view, this is like the perpendicular, so it will not be visible. Now in the side view, the inclined surface we need to see. In the side view, this corner point is matching over here, and this is another corner point in the side view that is matching over here, and this is another corner point. That corner point is matching here in this corner point. This corner point is matching over here. So the inclined surface is like this. So take line command, join like this. So this is joining with this, and then this is joining over here. But when you see the side view, this is the principal surface which we will be seeing, and this is the curved surface, inclined surface, that also we can see. But the plane is hiding this curved inclined surface till this triangles area, it is hiding. So this line will not be visible. So this should be a hidden line. So now you need to change the properties of this line as hidden line. So now you can change the properties of this line as hidden line surface. So this is not visible. Now we completed the side view and top view, and front view. We come to the front. In the front view, we have drawn in the front view this triangle, this principal plane, and this is the skew surface. This skew surface is actually visible in the front view, top view, side view. So in the top view, this is appearing, it is coinciding with this actually. That is why we have not given any hidden lines here. And this skew surface in the side view, it is appearing over here. But in the same manner, this skew surface is appearing in the front view. And this corner point, to draw this skew surface, you need to first identify this corner point in the front view. So in the front view, the total height, the 40 mm, it is 60 mm. So this corner point in the front view is here. So now first you draw this corner point from here to here. This corner point is over here, and this corner point in the front view is here. So you join these two. Then again, to join this corner point over here, this side. So because it is 50 mm and this 50 mm and height is 60 mm, this corner point is the another corner point of the skew surface. So take line command, join this, and combine these two. So this is the skew surface which will be visible in the front view, and this is another skew surface, and the corner point of these skew surfaces are this 1, 2, 3. This corner point is here. This corner point is coinciding with this in the front view, that is this, and this corner point is this. So these are the three corner points. It will appear like a triangle. So you join these two, already joined, so you can join this. So this is the front view. Front view will be looking like for this the diagram like this. So this is the front view, top view, and side view. So this is the question number we can give, and dimensions also can be given. So with this it is completed. So this diagram. So one more I told you to I will complete. So one more we will take. So that is the last diagram, so that we will be completing. So we will try to see this and we will draw this little small. It's not moving. So this diagram, so this is also easy, strictly speaking. So this is the principal surface, this is another principal surface, and this all principal surfaces only. We can easily draw this. Only thing is we will not even get hidden lines, and here we will get the hidden lines curve. Okay, we will check. So now this is over, so I will the copy. So maybe this is bigger size diagram, so we will try to draw only one diagram here. So now I will delete this. So now I will try to draw this diagram. So first I need to start with the front view, and this front view and side view is right side view will be drawn on left side. So first I will draw the front view this side. So now if I go to the front view, now first where to start? This is the principal surface. Surface I will draw this. So you see the dimensions 1 2 3 4 5 6 60 mm, and height is 1 2 3 4 5 6 7 8 mm. So 80 mm. So now I will draw this principal surface by taking 8 mm. 1 2 3 4 5 6 7 8 mm, and this is 60 mm 4 5 6. So here by taking this dots count, I have selected 6 1 2 3 4 5 6 mm, and this is 8 mm. So now I will join this line. I will join. Now I need to join this corner point to this corner point. It is coming straight. So now it is 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 only. So I need to go little more height. So okay, now this is not required. So now, and this is 50 mm, so it is correct. Now I will draw a line from here to here. So now you check the grids also properly given, and now there is one circle, it is joining at the center of the. So let me also complete before I draw this arc. I will complete this entire thing. Now I will try to draw this surface. This is also a principal surface, so I will draw this. So again I need to take 20 mm here. So take a line command 20 mm, and the total height 80 mm, and it is joining it with this. Okay, so now this circle is drawn exactly at the center of the plane. So now this diameter we need to check. So it is exactly coinciding with this. So we need to check the diameter, and the diameter I will take a circle command and circle, and then maybe yes, I can see this is coinciding with this. So because here if you draw and it is coinciding with this dot, that means here they maintain 10 mm, and here also they maintain 10 mm. So this is the diameter maybe from here 1 2 3 30 mm, radius is 30 mm. So now this I will keep as it is, because in order to see this, so now you check the grids also. The grids also will appearing like this, and this line is not there, this line. So I will trim this line. And this is one surface, principal surface, that is this, and this is the another principal surface, that is this side, and this is the front view of this. Now I will draw the top view. If I go to the top view, so now I will move this diagram little above, so that I can draw the top view comfortably. So now I need to draw the top view, this shape. This is full width. So full width I already know, and the thickness 1 2 3 4 5 6 60 mm. So take a line command. So with the full width I have drawn this, and with 60 mm 1 2 3 4 5 6, and then 10 mm here and again 30 mm, 1 2 3 30 mm, and I will be coming back here and complete this. So this is the principal surface which I can able to see in the top view. So these two are over. Now if I see the other the surfaces, this is the inclined surface that is visible, and that is the inclined surface that is also visible. So that I need to draw. So before I draw, I will be going to the side view. So side view, I will draw this the principal surface, and which will be, this edge will be very near to the front view, so I will be drawing this. So this is the front view, side view, and this is the near to side view. So then this is 30 mm. So 30 mm I will draw, and I will complete this rectangle. I will complete this rectangle. So this is the side, and I need to, now all principal surfaces are over. Now I will go to any one the curved surface, or before I go to the curved surface, I need to first complete the inclined surface. Where is the inclined surface? This is the inclined surface that will be seen in the top view. So top view. So now first I will be identifying this inclined surface corner. So this inclined surface corner is here, and this distance I don't know exactly how much it is the distance. So but I can only know that this inclined surface is over here. So now I can take a line command, and I need to use the projections. I need to use the projections here now. So because, so now if I use, this is the inclined line in the front view, and if you see the top view, the inclined surface is visible over in this area. So now I need to use the projection line from here and draw the projection line, and these dimensions I will remove first, or otherwise it will not come till there. So I will just draw the projection line till here. Okay, so this is also will come, this curved surface, this line also will come in the top view, so which will be visible here. So I will complete this, but here I wanted to first complete this inclined surface. This first let me complete that inclined surface only. So this is the line which will be joining from here to here. So till here actually it is the projection line, this projection line, and from here to here, let me complete. This is actually the line. So I will just complete this. Let me, sorry. First I will draw the projection line from here to here, and here to here actually the line, and this is the line which is actually making another the boundary, these two corner points. That two corner points will be, this corner point will be another line which is joining these two. So I will join these two. So and this corner point I need to locate. This corner point is, when you join these two lines, on this line this corner point will be visible. That means the corner point will be on this line, and this corner point, the width I need to know. And if you actually project this corner point to get, if I draw this point, if I draw the vertical projection line, wherever it intersects, that is the corner point here. So I will be taking the projection line. So I will draw. So I will off snap F9. Now I will be taking the corner, because this is not coinciding with any one grid point. So I will be taking the vertical projection line. I will on F8 in order to make the vertical line. So here wherever it is intersecting, this is this corner point. And where is this corner point? This will be, this corner point is line joining this. This line joining is already there, and wherever it intersects, this is the thing. So this area is here. This area is here. So you can join these two, the lines by joining these all lines. Sorry. So we can able to complete this surface. This is the surface. Now these are all actually imaginary lines. So I will change the properties of this projection lines into red color. So this is the red color, and this I have drawn another line, so it is not the projection line. Okay, so this is the surface. Now in the similar manner, I need to get this inclined surface. This inclined surface corner points, this is the one corner point, this is another corner point. These two corner points already known, and these two corner points of this inclined surface will be visible, one on this line, another one is on this line. But in order to get these two, I need to project from here. So that means this is the inclined surface, this is the inclined surface, and this is the end point of this inclined surface. So I need to draw the projection from here. So take the projection line. So from this corner point and draw the vertical projection line and till this surface, and wherever it is intersecting, these are the two other corner points of this surface. Now I will be drawing the another line onto this, because it is the imaginary line or the projection line. Sorry. So take line command. So from here line command to here, this side till here, and then from here to here I need to draw another line, and this anyhow it is a inclined surface. This is the, I will change the properties of this. This is the projection line. So with this I completed this two inclined surface. But what about this curved surface? That curved surface is this only. So finally I completed in the top view this surface, this two inclined surface, and this is the curved surface. But here if you identify properly, this is the curved surface which will be inside, but here this is the boundary. This boundary will make one the edge in the curved surface. This is the curved surface. In the top view, if you see, the boundary of this curved surface is, one curved surface is here, and another side another line will be visible here. So I need to draw the projection line, and from here to here there is a hidden line which actually the boundary of this curved surface. And again this is the curved surface. No, this curved surface boundary will be here in the top view. So here in the top view. Okay, now I can match the properties. This is the projection line, this is also projection line, but these two are the hidden lines. So immediately we better to change the properties of hidden line. So hidden line properties I will be changing. So this is the hidden line, and this is another hidden line. Okay, now so with this so we can able to see how we can able to complete this. So this is the top view. Top view is over. Now front view is also over. And side view, again in the side view, these two becomes the curved surface boundaries. So that I need to draw here. So that becomes that actually make the hidden line. So this curved surface in the side view is not drawn. So I need to draw this curved surface. I need to draw in the side view. So this is the, again to locate the boundaries of the curved surface. This point, these 2 points I need to check in the on the side view. First I will draw this curved surface lines. This is the 30 mm. So this is the 30 mm, 1 2 3. So I need to on the snap, F8 F9, and then I need to identify these 2 points. These 2 points will be on this corner point. That corner point is here. So now I need to project this. I will off F9. The ortho is already on, so I will take the corner point F9, take this point, and ortho I should on. So draw the projections. So it will be on this line. So then again this curved surface in the side view, it will be coming all the around. So now you take a line which is vertical till here, and this is completing. Actually this line will be visible, and this is making a full length in the side view, and this is the curved surface. That means that curved surface is over here, and these are the boundaries. So you can I can take trim, and I will draw one more line from here to this intersection point to this intersection point, and this is the projection line. The similar manner, this is another curved line. So here if you see this corner points of the hidden line, this hidden to this inclined surface corner point is these two are coinciding with this, and these two lines, these 2 points are coinciding somewhere, and I need to draw the projection. So if I draw the projection from here, so it will be coming somewhere here like this. So these are the other two corner points, which indicates that this is the curved surface. So okay, now I will draw the another line over here. Now these are the projection lines. I will change the properties of this projection line. These are the projection lines properties, and these are the hidden lines. Now here this is the plane surface in the side view, but here you need to identify where are this curved surface. This curved surface, the hidden lines we need to identify. So first we need to identify in the side view. When you see, these are the two boundaries of this curved surface. So draw the projection line from here to here, and again you draw the projections of this surface from here to till this. Now if you see the side view, this curved surface, this inclined surface I already drawn, but there is no other material to hide this surface, curved surface, till here. But here it is, this surface is hiding till here. That means till here this surface is hiding the curved surface. So till here hidden line will be there, but here there is no material to hide the surface. So I will be actually trimming this till here. Okay, so this is only hidden line from here to here. So even I need to trim this. I will draw one more line over here above this. So this is the hidden line. And then this is the projection line. So projection line I will keep here with the red mark. So now if you see the down, now this is the boundary. So this is the surface which is hiding this the curved line, curved surface boundary, and it should be hidden line. So it should be hidden line. So till here to here it is a projection line. Later it will be hidden line. So even here this curved surface is here to here till here. These are the corner points, but this hidden line is coming below this surface, so it will be also a hidden line. So now I need to change the properties of this line as hidden line, and even this is also a hidden line, and this is the projection line. This is the projection line. So likewise we need to draw. So it is taken some little time, but once after you complete understand the diagram, so it will be very easy. So if you take the printout of this, you can able to see very clearly how it is actually appearing the diagram. So now let me go to the print. So with the color print only. So I will go to the previous plot, and I will be taking the window with the fit to paper. Now fit to paper window at the center with the custom 1:1 scale. Will take the window. So this window I will select. Now you check the preview. So if you see the preview, you can able to see all the dots, everything properly. So okay, sorry, why it is 1:1 scale. Okay, now I have taken the paper size more, so I will be taking a A4 size papers. So there is no A4 size paper here, the JPG. So let me go to the publish, not in JPG, drawing to PDF. And the full bleed ISO A4, and then I will take the window. So already it is selected actually. Now if you see the preview, sorry, it's not coming. So 1:1 you should make. Now you see, now you can able to see the dimensions I have not given, so hidden lines, everything we can able to see. So these are the hidden lines will be the projection lines will be very thin. So that is how we can able to complete this diagram. Thank you.